Okay, in this video I'm going to go over the Chapter 6 test review. These want me to simplify my expressions. I can rewrite this as log base 9, 9 to the 1/2 to the x, which I can distribute is going to turn into log base 9, 9 to the 1/2 x. Log base and my numbers cancel out, which leave me with 1/2 x. Over here, the log base and the 7 cancel out, so I'm left with negative 3x. Over here, e and ln are inverse operations, so I'm left with 20. Number 2 just wants me to rewrite the inverse of the functions to write them as logarithms. This is going to be log base 64, because my exponent base is 64. And the 4 and the 1/3 switch bases. This one's an equation, so I want to switch my x and y. Not e. Then, to get rid of the logarithm, I want to raise it to its log base. So the log base of ln is e. So I'm going to have a base of e with an exponent of x, a base of e with an exponent of ln y minus 4. My e and ln cancel out, so I have e to the x equals y minus 4. I want to isolate my variable. I add 4 to both sides. Y equals e to the x plus 4. Over here it doesn't set it equal to y, so I will. I'm going to switch my x and my y, so I have ln of 3y plus 4 equals x. Then this 4 is not with the logarithm, so I'm going to start off by subtracting that. I have ln of 3y equals x minus 4. To get rid of my natural log, I raise them both to exponents. And the whole x minus 4 is part of my exponent. The e and the natural log cancel out, so I have 3y equals e to the x minus 4. I want to go ahead and divide both sides by 3. I get y equals e to the x minus 4 over 3. These ones want me to expand, so I'm going to split them up. I have ln of 7 plus ln of x to the 5. Remember, numbers and letters get split up. Then I'm going to have minus ln y cubed, because that's on the denominator. Exponents need to move in front of my logarithm. So I have ln of 7 stays the same, plus 5n ln x minus 3 ln y. Over here, all of these are being multiplied together, so they're all going to get split up with addition. I have log base 8 of 3 plus log base 8 of x plus log base 8 of y cubed. The y cubed has an exponent, so I'm going to move that out front. My first two terms stay the same. On my last one, I want to split up everything. Remember, numbers get their own, so I have log 3 plus log y, because both of those are being multiplied on the top. And then my x is on the bottom, so I have minus log x. No exponents, so I'm done there. These ones I'm condensing, so numbers up front are going to become exponents. So I have log base 7, 4 cubed, plus log base 7 to the 6, minus log base 7, 8. 4 cubed is 64. Then I want to condense it some more. So my 2 that are being added are going to turn into multiplication. So I have 64 times 6. And then the 8 goes on the bottom because it's division. I'm going to type this into my calculator to see if it simplifies nicely. So I have 64 times 6. And then I want to divide that by 8. This one does. It's 48. I can't take the log base 7 of 48 nicely, so I'm just going to leave it like that. Same thing on b. I want to move this as an exponent. So I want to go ahead and make this my exponent. So I have log base 2 of 12 minus log base 2 x squared. Because they're separated by subtraction, I want to go ahead and make this a fraction. and that is my final answer since I can't do anything with variables. C, same idea. Numbers up front become exponents, so it's going to be ln x squared plus ln 2 to the 5th power minus ln 8. 2 to the 5th power is 32. Then I want to put it all together in one logarithm, so I have x squared times 32 divided by 8. I want to simplify this if I can. If not, I want to rewrite it in better order. Lucky for us, 32 is divisible by 8. That gives us 4x squared. Number 5 says the population of a city is 40,000 and the annual growth rate is 1.6%. Write an equation to model the population y after x years. So this is going to be y equals, I'm starting off with 40,000. And in this one, I'm using y equals my initial amount times 1 plus my rate to my t power. So this one's telling me to use y and x. So 1 plus 0.016 because I take my rate and divide by 100. And then instead of t, it wants x. I think on Canvas it's going to want you to simplify this just a little bit. So I'm going to have 40,000 times 1.016 to the x is what it's going to be looking for. What's the population after 8 years? I'm going to take 8 and plug in for my x. So I have y equals 40,000 times 1.016 to the 8. And then I just go ahead and type into my calculator. I'm talking about people, so I'm going to round to the nearest whole number. So 45,416. People. How long does it take the population to double? There are two ways I can actually do this problem now. I can set it up as a logarithm and solve, or I can go ahead and graph. I'm going to show you with the logarithm way because I have shown you how to graph before. So I'm going to set it equal to 80,000. My first step is to divide out the 40,000, which gives me 2, equals 1.01 to the x exponent. Then to solve as a logarithm, I need to get rid of this. I'm going to make it log base 1.0161, no, 16 of 2, and then I'm going to do the same thing to my right side. On my right side, those just cancel out, and it leaves me with the x. So then I just need to type this part into my calculator. I'm going to do math log base 1.016 of 2, which gives me 43.67. So I was measuring in years, so I'm going to say about 44 years. If I went ahead and graphed y equals 80,000 and y equals the 40,000 times 1.016 to the x, they should also cross at the same spot. This one says the amount of y in grams of radioactive isotope fermium-253 remaining after t hours is y equals a to the 0.5 to the t over 72 power, where a is the initial amount in grams. Is this growth and decay? Before I can figure this out, I want to rewrite this because I don't like that 72. So I want to take 0.5 to the 1 over 72. Which gives me 0.9592. So this is less than 1. It is decay. What percent decays each hour? So I want to subtract this from 1. Which gives me 0.0408. On the test, it'll tell you how many decimal places. I'm just doing 4 to be safe. And then to turn it into percent, I want to multiply by 100. So 4.08%. Number 7 says I deposit 500 into an account that pays 6.5% each year. And then it wants me to find the balance if it's compounded each of these. It doesn't say, I'm going to assume 1 year. If it's compounding anything besides continuously, this is the formula I want to use. The A equals P times 1 plus R over N to the NT. And if it's compounding continuously, it's PERT, the P times E to the RT. So, annually, I'm going to plug in. It's going to be 500 times 1 plus 0.065 divided by 1 times 1 to the 1, because there's 1 year in a year. This gets me 532, and this is money, so 2 decimal places, 50 cents. Semi-annually means my N is 2. So I plug in, everywhere there's an N, I'm going to put a 2. This gets me 533.3, 03 I meant. Quarterly is 4. So I have 500 times 1 plus 0.065 over 2, nope, 4. Times 4 to the 1. So I'm going to replace those 2's with 4's. This one gets me $533.30. Next one is monthly. There are 12 months in a year. Can I go ahead and enter that? Which gets me $533.49. My next one says daily, 365 days in a year. At least we assume so in math. So then I want to go ahead and change that. Oops, 120. Oops, I forgot my parentheses. There you go. So $533.58. Okay, and then my last one is continuously, so this is using the PERT formula. So I'm going to go ahead and type that in. 500 e to the 0.065 times 1. That says $533.58. So in a year, it's almost exactly to the daily amount, just because my initial amount was so small. C says if I deposit the initial amount of 500 in the account in 2012, in what year will it reach 1020? It doesn't say what compounding frequency to use. I'll use E. So I'm going to do 1020 equals 500E. I know my rate is 0.065, and I don't know my time. Again, I can graph this. I'm going to solve it using logarithms because we now know how. I'm going to divide both sides by 500. 1020 divided by 500 is 2.04. Then I want to get rid of my e, so I'm going to take the natural log of both sides. On my right side, the ln and e cancel out. I still have ln 2.04. I don't want to type that in until the very end. I want to isolate my variables, so I'm going to divide both sides by 0.065. So I have t equals ln 2.04. This whole logarithm is going to be divided by that. So I want to close it off when I type it in the calculator. This gets me 10.96, so about 11 years. So 2012 plus 11 is 2023, this year. This one is giving me a table of values. I want to go ahead and type this into my calculator. I'm going to go stat, edit. L1, remember, is your X. L2 is my Y or labeling. To clear this, I arrow up, I press clear, I press down. So over here I go to L2, I press clear, and then I arrow back down. Sorry. I need some numbers. So I have, for my L1, I have 1, 2, 3. And then for my L2, I have 36, 37.44, and 38.9376. I go second mode, I go stat, calc. This is an exponential equation, so I want to choose 0 on my calculator. It might be 9 on older calculators for exponential regression. I go down to calculate, and press enter, and it gives me this. So my initial value is my A. So 34 point, I'm going to do 4 decimal places because that's what they did. 6154. My common ratio is another way of saying my B value. So 1.04. My 1 unit growth factor is again my common ratio. My 1 unit percent change, this is where I want to subtract 1, is 4%. Oops, 4%. So I take that decimal and multiply by 100. My function, I just plug this back in, so y equals 34.6154 times 1.04 to the x. G of 6 is me plugging in 6. Oops, 34. Again, I'm going to round the 4 decimal places, so 43.7995. Okay, this one wants me to graph the equations and answer the following questions, so I'm just going to graph this on my calculator. I have 4 e to the negative 2x. To get my actual values, I go second graph to get my points. I'm just going to do 0, 4 because I need to know my y-intercept. And then let me go back to the graph and sketch it. So this one is getting smaller as I go to the right. This is dk. My y-intercept is that point I said, 0, 4. My domain, it's going left and right forever, just slowly going left. So this is negative infinity to infinity, or on the test, it might be all real numbers. Any of these combinations are ways to write it. My range, everything is greater than 0. So if I'm writing it in interval notation, it's 0 to infinity, or in inequality notation, y is greater than or equal to 0. Equation of my asymptote, the line it gets really close to but never crosses, is y equals 0. Okay, same idea for number 10. I'm going to go ahead and graph this one. 3 to the x minus 2 plus 1. Go ahead and graph it to just kind of see it, and then I want to see where it's crossing the y-axis. That is at 1.1 repeating. Kind of looks like this. So this one is growth because it's going up and right. This one, my y-intercept is 0, 1.1 repeating. My domain, again, is negative infinity to infinity. So for exponential equations, the domain is all real numbers. For logarithmic equations, it's my range that's always all real numbers. My range here, because of this plus 1, is going to shift it up 1. So it's going to be 1 to infinity, or y is greater than or equal to 1. And then the equation of my asymptote matches that, so y equals 1. On number 11, I'm talking about transformations. This one is a negative up front, reflection. If it specifies, it's going to be x-axis. Doesn't always. And then the minus 4 means shifts right 4. Over here, to go from here to here, it's just a 2 up front, so it's a vertical stretch when it's a whole number. This 2 is the whole number. So it's a vertical stretch of 2. Over here, both equations have that negative in the exponent, but this one has a 5. This isn't going to be on the test, the 5 part, but it's a horizontal shrink of 1/5 for compression. And then it's shifting down 8. Over here I have a 1/2 up front. That's a vertical shrink or compression of 1/2. Fractions and numbers less than 1 are typically vertical shrinks. And then this 5 on the inside is shifting it left 5. Okay, one last problem on the back. It says, Grace bought the iPhone for $850. After 1 year, the estimated value of the phone is worth $569.50. Is this growth or decay? Decay, because the value is going down. What is the factor of growth or decay? So, I want to set this up. My formula is typically y equals a times b to the x. I know my x is 1. I know my y is the 569.50, and I know I initially started off with the 850. So I'm just going to solve this over here. So 56.950 equals 850. I don't know my b value. I do know it's 1 for my time. So I'm going to divide both sides by 850. That gets me 0.67. This is asking for the growth or decay factor. So 0.67 when it's asking for the factor. When it's asking for the percent change, this is where I subtract from 1. So this gives me 0.33 times by 100 is 33%. Use the function to determine the value of the iPhone given the number of t years after. So y equals, I know it starts off at 850, then my number in the parentheses is 0.67, the growth or decay factor, and then it says it's t years. When will it be worth approximately $15? So I set this equal to 15. I can graph, or I'm going to use logarithms to solve. So first thing I'm going to do is I'm going to divide both sides by 850. Is this a fraction? I'm going to leave it alone as this fraction, 3 over 170 for now. Then I want to get rid of the exponent, so I'm going to make both of these log base 0.67. Oops, not 7. On the right side, the log base and the base cancel out. So I have log 0.67 of 3 over 170 equals t. And then I just type that into my calculator. So math, choice 9, not choice 9, choice A, 0.67, 3 over 170, gives me 10.8, or 10.08. So about 10 years after purchase.